Hello everyone, welcome to my channel. My name is Mr.Adebanjo and I want to welcome you to this video. In this video we are going to be discussing together Wassce 2025 further mathematics, the theoretical part of the questions. In our previous video we discussed the objective part of this question, and I promised that we are going to be discussing the theoretical part of the question in the next video, which I've come to fulfill in this video. So we are going to be discussing together extensively on the Wassce 2025 further mathematics, the theoretical part of the question. So it means that if you have not seen the objective part of the question, please you can check the YouTube channel where you will see the video there, or you check the playlist of this video, you will find the objective part of this question there. You really need to see the video so as to have the complete package. So what are we going to be doing in this video? In this video, I'm going to be telling you the topic where each of the question asked emanate from, and also we are going to be solving each of the questions step by step together in this video. And also we have 15 questions to solve all together in this video. But before we get it started, if you are yet to subscribe to this channel, please click the subscribe button on the channel right now, and so that you will be notified whenever we post information on this platform. And we are using this opportunity to appeal to all our viewers out there. Please don't keep this video to yourself. Please share this video on all the platforms that you belong to, all the social media platforms that you belong to. Please, we are appealing to you that you share the video on all the groups that you belong to. Share this video. There are a lot of students out there who are desperately in need of this resource material, and they never have any clue about this platform, and the only way you can get across to them is by you sharing this video. By the time they see this video, they will be aware of this platform. And don't forget to share this video, subscribe if you're here to subscribe, and comment in the comment section of this video so as to help us improve in our next video. As you do so, may the good Lord bless you. Now the first question is what you are seeing on the screen right now, and the question is from the binary operation. The question says that a binary operation asterisk is defined on a set of real number R by x asterisk y equals to 2x plus 2y minus xy over 5. You have to find the inverse of x under the operation asterisk. So you have to find the inverse of this x under this binary operation asterisk. Now we know that when it comes to binary operation, before you can find inverse elements, inverse of an element under a binary operation, we need to find the identity element first. So you need to find the identity element before you can find inverse element. So that means you're going to find identity element of this x first before you can find its inverse. So what is the condition for finding the identity element of a set? So that means the identity element, which is represented by E, were combined with this element x under this binary binary operation should give us x. So that means the condition for finding the identity element of this element x is that x asterisk E should give us ex back. That is to say that if I combine this element with its identity under this binary operation asterisk, it should give me x back. So what does this simply mean? That we can put this into this rule. We have x asterisk y, so we are having x asterisk E here. So that means our s stand for x here, and our E will represent y here. So you can now put that into this rule. So that means we'll be having 2x plus 2e minus xe over 5 equals to x. So if you put this into this rule, you'll be having okay, where e is identity element, so we'll be having 2x plus 2e minus ex over 5 equals to e. So our aim is to find the value of E, which is the identity element, before you can find the inverse element. So what do? Of course, we can multiply through by 5. So if I multiply through by 5, so as to clear this denominator, so I'll have 2x plus 10e minus ex equals to 5x. So from there now, we can now collect the like terms. So you can take this 10x to this side, so that I'll be having a 10e minus se equals to 5x minus 10x. So from there, our aim is to find e. So we can factorize e out here. So if you factorize e, you'll be having e into 10 minus x equals to 5x minus 10x will give us minus 5x. Our aim is to find e. You can divide both sides by 10 minus x. So that means the identity element will be minus 5x over 10 minus x. So this is the identity element of x. So now that we now have the identity element, you can now go ahead and find the inverse element of x. So knowing that if I combine the element ex with its inverse under the binary operation aesthetic, it should give me the identity element e. So that means the rule for finding an inverse element should be x aesthetic is inverse should give us the identity element, and that's the reason why we find the identity element first before finding the inverse element. Now that we have the identity element, which is represented by this e, and we are looking for the inverse of x, which is x raised to power minus 1, then if you put this into this rule as well given to us, so that you'll be having 2x plus 2, so that y will be represented by the inverse of x, which is x raised to power minus 1. So you'll be having 2x plus 2 x raised to power minus 1, then minus x multiplied by x raised to power minus 1 over 5 equals to the identity element, which is what we're having here. So if I put that here, I'll be having this. So I have 2x plus 2x raised to power minus 1 minus x raised to power x raised to power minus 1 over 5. That is to say that in this rule, our x inverse here is representing y. So wherever you see y, you put x inverse. So that will give us what you have at the left hand side here, equals to the identity element, which is what you have gotten here. So from there, now I can now simplify to find the inverse. So what can we do? We can okay, you can multiply through by 5, so as to clear the denominator here. You can multiply through by this 5, so as to clear the denominator at the left hand side. So if I multiply through by 5, I'll be having 10x plus 10 inverse of 10x raised to power minus 1 minus x raised to power minus s multiplied by x raised to power minus 1 equals to 5 times minus 5x will give us minus 25x over 10 raised to power over 10 minus x. Then from there, what can we do? I can collect light. I can take this 10x to this side, so I'll be having this left here. So we'll be having 10 raised to 10 x raised to power minus 1 minus x multiplied by x raised to power minus 1 equals to minus 25x over 10 minus x minus 10x. So from there, you can make this one a single fraction, and you can now factorize x raised to power minus 1 from here. So if I factorize x raised to power minus 1 from here, I'll be having x raised to power minus 1 into bracket 10 minus x equals to, I can find the LCM of this right hand side, which is 10 minus x. If I find the LCM, I'll be having 10 minus x. 10 minus x in 10 minus x give us 1. 1 times minus 25x will give us minus 25x. Then minus 1 in 10 minus x, that gives us 10 minus x times 10x. That gives what you're having here. Then from there, if you simplify the right hand side further, so we have minus 25x. If you expand this bracket using minus 10x, that gives us minus 100x plus 10x squared over 10 minus x. From there, you can still simplify this side better by saying that minus 25x minus 100x, that gives us minus 120. That will give us minus 125x, then plus 10s squared over 10 minus x. So we can now divide both sides by 10 minus x so as to find the inverse of x. So that would be having here. Then from there, we can change this one to times by inversing this fraction. So if I inverse this, that will give us 10 times 1 over 10 minus x. So that will give us what you're having here. Then from there, so this denominator can multiply themselves. So 10 minus x times 10 minus x will give us 10 minus x all squared. So that means we'll be having 10x squared minus 125x over 10 minus x all square, which is the inverse of the element of x that we have to find. So that's the solution for question number 1a. Question number 1b is the continuation of the question we have just solved. We have to find the true set when m asterisk 7 is equals to minus 2 asterisk m. So all you need to do is to remember the rule given to us in the previous question. We are given this rule: s asterisk y equals to 2s plus 2y minus s over 5. So we need this rule here to solve this question. So here we are having m asterisk 7. So that means your m will be replaced by x here. So you replace x by m and replace 7 by y by 7. So you now put that into this rule. So that means I can find m asterisk 7. So m asterisk 7 give me 2m plus 2 times 7, which will give us 14 minus 7m over 5. Then also you can also simplify minus 2 asterisk m. You can put that into this as well. So minus 2 replace x, then m replace y. So you'll be having minus 4 plus 2m plus 2m over 5. In as much that our 2 is replacing x here, so 2 times minus 2 give us a minus 4. Our m is replacing y, so you'll be having plus 2m. So then you're having minus 2. Minus times minus give us plus, then y is a m over 5. So these are meant to be, so this will be equal to this now, according to the statement you're having here. So we'll be having 2m plus 14. Okay, this you are reiterating this what you have to solve. Now that we know our m asterisk 7, which is this, and our minus 2 asterisk m is this, so you can equate them. So having equate them, you can now collect like times to be able to find the true set of m. So what can we do? We can multiply through by 5 so as to clear the denominator. So if you multiply through by 5, you'll be having 10m plus 14 times 5 give us 70. Then 5 times this will give us a minus 7m. Minus 5 times minus 4 give us minus 20. 5 times 2m will give us 10m. Then 5 times 2m over 5 will give us a 2m. We can now collect like times 10m plus minus 7m will give us a 3m plus 70 equals to minus 20 plus 12m. Take the like times also. You're having 12m minus 3m equals to 70 plus 20. That should give us 9m equals to 90. Divide both by 9, m will be equals to 10. So our m is 10, but because I say we should put it in set format. So that means we'll be having set m, since this is the element using small letter m. So that means the set will inherit the capital letter m, having m elements such that m is equal to 10. So this is how to put it in a set through sets. So that is the solution for question number 1b. Question number 2 is from combination. Is from combination. We are given that s combination 2 plus s combination 3 minus 4s equals 0, where s is a positive integer. We have to find the value of x. So like I told you, this question is for combination. So how can we write this? S combination 2 means s factorial over s minus 2 factorial 2 factorial plus s combination 3 means s factorial over s minus 3 factorial 3 factorial minus 4x equals to 0. From there, you can simplify this further by expanding s factorial here, so as to take care of s minus 2 factorial to take care of s minus 3 factorial. So if you expand this, that will give us s into bracket s minus 1 into bracket s minus 2 factorial. Why do we stop here? So that you can cancel out s minus 2 factorial there. Then also you can expand s factorial also to be x into s minus 1, s minus 2, s minus 3 factorial, so as to get rid of this s minus 3 factorial under. So now what do we have? This will cancel this, then this will cancel this. That means we'll be left with s into s minus 1 over 2, because 2 factorial is seen as 2. Then also 3s minus 3 factorial will cancel s minus 3 factorial. Then 3 factorial is 6. So you'll be having x minus s into s minus 1, s minus 2 over 6 minus 4s is equal to 0. Then from there, what can we do? We can multiply through by the LCM of denominators. The LCM is 6, so I can multiply through by 6 so as to clear the denominator. So if I multiply this one by 6, 2 will go in C, you'll be having 3. So you're having 3s into s minus 1. If I multiply this one by 6, 6 will cancel 6. I'll be having s into s minus 1, s minus 2 minus 20, because 6 will multiply minus 4x, that gives us minus 24x, and 6 multiplied by 0 give us 0. So from here we can expand the brackets. If I expand this bracket, that gives us a 3s squared minus 3s. Then I can expand these two brackets first. That will give us this. Then minus 24 equals 0. Then I can now use this x to expand this bracket again. Or before that, minus 2s minus x will give us minus 3x. So then you can now use this x to expand this bracket, and that should give us s cubed minus I've already collected like times the minus 2x minus s will give us minus 3x. The minus 3s times s will give us minus 3s squared. Then s times 2 gives us 2x. Minus 24 is equals to 0. Then from there we can take the like times. We are having 3s squared minus 3s squared. That should give us 0. Then we are having s cubed here, so we'll be having s cubed. Then we are having minus 3x plus 2x minus 24x. That will give us a minus 25x equals 0. So from there we can simplify this further by factorizing this. S is common here, I can factorize x out. So that will be having x into s squared minus 25 equals 0. So which simply means s is equal to 0 or s squared minus 25 equals 0. So that's what this one means. So the first value of x is 0, but we are told that we have to find the positive integer. So that means our answer cannot be 0. So now you can simplify this one further, because this one is a difference of 2 squared. We are having s squared minus 25 equals 0. So that is a difference of 2 squares, which we can simplify this further by saying this is 5 raised to power 2, and that shows that this is a difference of 2 squares, which can be written as s minus 5 into s plus 5 equals 0. Then each of them will be equal to 0. Then you can now find our s equals to 5 or s equals to minus 5. Therefore our s equals to 5. So the value of our s is 5, which is the solution for question number 2. Question number 3 is from polynomial. We are told that a function f is defined by f of s equals to 72 over ps plus r, where p and r are constant, given that f of 6 is equal to 12 and f of 7 is equal to 9. We have to find the value of p and r. So I can say this question is from function. I can also call it a polynomial, but nevertheless, so this is a function. Now, so we are given that this f of a is equal to this. We are now given f of 6 is equal to 12 and f of 7 is equal to 9. So if you put f of 6 into this function, that should give us 12. That will enable us to get that's answer in terms of p and r. And you can also do that for f of 7 and equals to 9. Put that into this, you'll be able to get two equations to solve simultaneously. So what do we do? So we are having f of 6 equals to 12. So that means I will put my 6 in place of x in this f of x. So that means I will be having 72 over 6 times p. That gives us 6p plus r equals to this 12. From there, you can collect like times by cross multiplying. If I cross multiply, 12 will multiply 6p plus r equals to 72. You can expand the bracket or divide both sides by 12. So if I divide both sides by 12, I'll be having 6p plus r equals to 6. So that should give us equation 1. Then for the second one also, f of 7 is equals to 9. So that means anywhere we see x in this function, we can put it to be 7. So that means we'll be having 72 over 7p plus r equals to 9. You can cross multiply also. Be having 9 into 7p plus r equals to 72. We can divide both sides by 9. So we'll be having 7p plus r equals to 8, which give us equation 2. We can now solve equation 1 and 2 simultaneously to find our p and r. So what do we do? You can eliminate this our r here, since r is an area, they are also already equal. So we can just subtract equation 1 from equation 2. So subtract equation 1 from equation 2. I'll be having 7p minus 6p that give us a p. And I'll be having r minus r that give us 0. So 8 minus 6 will give us 2. So that means our p is equal to 2. We can now put the value of p into equation 1 or equation 2 to find the value of our r. So substitute p is equal to 2 into equation 1. So equation 1 says that 6p plus r equals to 6. So that means I'll be having 6 times 2 plus r equals to 6. That gives us 12 plus r equals to 6. Then r will be equal to 6 minus 12. Then r will be equal to minus 6. So therefore, our p is equal to 2 and our r is minus 6, which make the solution for question number 3a. Then the question continue because it has b. So question number 3b. Okay, I now rewrote the function, the full function now. That means we'll be having f of x now 72 over our p is 2. If you put that here, you'll be having 2x, and our r is 6, you'll be having minus 6. So this is the original function we're meant to have. So the question continues in the next slide, where we have to find another thing. Let's see what you have to find. You have to find the inverse of f of f inverse of 5 over 3. So you have to find f inverse of 5 over 3. That means you have to first of all find the inverse of this function. So when you know the inverse of this function, then we'll now be able to find f inverse of 5 over 3. Then how do we invert this function? The first thing to do is to f of x can also be called y. So I can call this f of x y. So I'll be having y is equal to 72 over 2x minus 6. Then we need to make this s subject to the formula. So we need to make s subject to the formula. What do? We can cross multiply. If I cross multiply, y will multiply 2x minus 6 equals to 72. Then from there, I can divide both sides by y. So I'll be having 2x minus 6 equals to 72 over y. Then minus 6 will come here. I'll be having 2x equals 72 over y plus 6. Then from there, I can find the LCM of the right hand side to make it a single fraction. 2x equals 72 plus 6y over y. Then I can now divide both sides by 2 to make our formula. So if I divide both sides by 2, I'll be having 72 plus 6y over y divided by 2. I can now change this one to times. So that will give us this times 1 over 2. Then that 2 will multiply this y here. That will give us over 2y. Then from there, what can we do? I think 2 can go in, 2 can go here, so we can factorize 2 here, so that I can cancel out the 2 under here. So that will give us 36 plus 3y over y. So now what do? We need to swap this variable. So I will change this one to y, and I will change this one to x. So wherever I see y here, I'll call it x. Wherever I see y here, x here, I'll call it y. So that means I'll be having y is equals to 36 plus 3x over x. So this y and this y, they are two different things. So this y here represents f of x. Then this y here represents f inverse of x. So this y is represented inverse. So which I can now write as f inverse of s is equals to 36 plus 3x over x. So now you have been able to find the inverse of this function. Now that we know the inverse of this function, we can now find the f inverse of 5 over 3. So that means our s is 5 over 3. We can now put that into this function here. So we'll be having 36 plus 3 multiplied by 5 over 3, then over 5 over 3. 3 can cancel 3 here. You'll be having 36 plus 5 over 5 over 3, and that'll give us a 41. This division sign can be written as divided by 5 over 3, which I can change this to times. That gives us 41 times 3 over 5. Then that gives us 123 over 5. You multiply out, and if you change this one to mixed number, you'll be having 24 whole number 3 over 5 as the value of f inverse of 5 over 3. So that solved the solution, the question number 3b for us. Question number 4 is from the partial fraction. We have to resolve this fraction partially. And how do we do that? The first thing to check is that we need to make sure that the degree of the power of denominator is greater than that of numerator, which is correct. This is quadratic and this is linear, so that is satisfied. Then we need to factorize the denominator first, so as to give us the brackets. So that's what we do first. Now the first thing I did is that I rearrange this denominator. Excuse me. So that gives us a minus 6x squared plus 25x minus 25. I only rearrange it so as to give us a a normal quadratic expression. Then after that, you will now factorize this. And how do we do that? You minus 6 will multiply minus 24 first. So minus 6 will multiply minus 24. So whatever you get, you now look for the two factors of the that number. That when you multiply together, give us the number. When you add them together, give us a plus 25 here, and that will be 16 and 9. So plus 16 and plus 9. When you multiply them, will give us the product of minus 6 and minus 24. And when you add them together, plus 16 plus 12 give us a plus 25. So plus 16 plus 9, that will give us a plus 25. So those two factors now will now replace minus plus 25x here. That will give us 16x plus 9x here. So that make this expression minus 6x squared plus 16x plus 9x minus 24. So that you can now factorize this. So here you can factorize this because 2x is common here, that can factorize. So that means we'll be having minus 2x into 3x minus 8. Then 3 is common here, that you can factorize. We'll be having 3 into 3x minus 8. Then you can now bring this together and pick one of the brackets. So you'll be having 2x over 7 over 3 minus 2x. I only rearrange there. You can write minus 2x plus 3, or if you like, and you rearrange it, that will be 3 minus 2x. Then you pick one of the bracket, 3x minus 8. Now at this point, now we have been able to factorize the denominator so as to get the two brackets. Now we can now resolve it partially now. So this fraction now will be equals to a over the first bracket plus b over the second bracket. Then from there, what can we do? We can find the LCM of this right hand side, and the LCM will be 3 minus 2s into bracket 3s minus 8. So that give us this. Then this in this, that give us 3s minus 8 multiplied by a, that give us this, plus this in this brackets, you'll be having 3 minus 2x, that will multiply b, that will give us this. Then from there, the denominator here will cancel the denominator here. You will be having 2s minus 7 equals to a into 3x minus 8 plus b into 3 minus 2x. So from there, we will need to eliminate b to find a, and we need to eliminate a to find b. And how do we do that? So we need to look for the value of x that will make this b 0. So the value of x that will make this 0. So that should give us 3 over 2. So when our s is 3 over 2, that will make this everything here 0. So we'll be able to find our a. So that means wherever you see x in this equation, you put 3 over 2. That way I'll be having 2 times 3 over 2 minus 7 equals to a into 3 times 3 over 2 minus 8. Because this one is already 0. Because if you put your 3 over 2 here, 2 will cancel 2. You'll be having 3 minus 3, that gives us 0. So that means you are left with this. Then from there, you can simplify this further. 2 will cancel 2. You'll be having 3 minus 7 equals to a into bracket 3 times 3 will give us 9 over 2 minus 8. Then if you find the LCM here, you'll be having minus 7 over 2a. Then from there, you can cross multiply here. That will give us a minus 8 is equals to minus 7a. Minus will take care of minus, so we'll be having 7a equals to 8. Divide both sides by 7, a will be equals to 8 over 7. Then also we need to eliminate a to find b. So that we need to find the value of x that will make this 0. And that should give us 8 over 3. When our s is 8 over 3, then this will make this one 0. You'll be able to find a b. So put that into this equation also. You'll be having 2 times 8 over 3 minus 7 equals to, everything here becomes 0. Then plus b into 3 minus 2 times 8 over 3. From there, if you simplify this further, 2 times 6 will give us 6 times 8 will give us 16 over 3 minus 7 equals to b into 3 minus 2 times 8 is 16 over 3 also. Then if you find the LCM here, you'll be having minus 5 over 3 equals to, find the LCM also here, you'll be having minus 7 over 3b. 3 will cancel 3, so you'll be having minus 5 equals to minus 7b. Minus will take care of minus, so you can now divide both sides by 7. Your b will be equals to 5 over 7. Now if you return the value of your a and b into this equation here, you will be having the value of your a to be 8 over 7, so that will be pulled here, and the b also will be pulled here. So that means the fraction will becomes this equals to 8 over 7 plus 5 over 7. So then 7 will come down, 7 here will also come down. So that means you'll be having 8 over 7 to bracket 3 minus 2x plus 5 over 7 to 3 minus 8. So that by like this, we have been able to resolve this fraction partially to get two simple fraction added together. So that's solve question number 4 for us. Question number 5 is from the statistics. In this case, histogram, which is one of the statistical tools for showing data. So in this, we are told that the table shows the distribution of the weight in Newton of 100 blood donors. You're having weight from having class intervals, and the number of donors representing the frequency. We have to draw histogram for this distribution. Now, to draw the histogram, of course, this is the weight which is in a class interval. Now, the first thing we need to verify is that does the class interval does the interval are they equal? Do we have equal class interval here? That was the first thing we need to verify. If we have the same class interval, then there's no problem drawing the histogram. But if you don't have, then there is a problem. So we are having 55 to 59. That means the interval should be 4 here. 60 to 65. That means the interval is 5. Then 66 to 71. The interval is 5. 72 to 78. The interval is 6. 79 to 86. The interval here is 7. 87 to 90. The interval is 7. So it does not have a constant class interval, so the interval varies. So that means we are not going to draw this histogram like the way you draw the normal histogram when they have a constant class interval. So what do? I'll write the frequency also, which is what you're having here. Then what do we do next? I'll find the class boundaries, which is gotten from the class interval. I will remove 0.5 from the lower class interval to get lower class boundary. I will add 0.5 to upper class interval to get the upper class boundary. So we have this, and you do that, that will give us this. Then from there, what do? We will now find the class size of this class interval, because that will be needed to find the frequency density. Now, what do? How do we find the class size? That will be this 60 minus 55 will give us a 5. Then 66 minus 60 will give us a 6. 72 minus 66 will give us 6. 79 minus 72 will give us a 7. Then 87 minus 79 will give us a 8. Then 90 minus 86 will give us a 4. So that's how to get the class size. Then having gotten the class size, we need to get the frequency density. Why are we doing this? Because this class interval does not have a constant class interval. If it does, that means we only need to find the frequency and the class boundary. We now plot the frequency against the class boundaries. But since it does not have a constant class interval, we will need to find the frequency density. And frequency density is calculated by finding frequency divided by class size. and that's the reason why we found this class size first, so that we'll be able to find the frequency density. So frequency density is a frequency divided by class size. So 18 divided by 5 gives us 3.6. 5 divided by 6 gives us 0.8. So it continues, but we approximate to one decimal place. 20 divided by 6 is 3.333, so 3.3. 22 divided by 7 will give us this. 27 divided by 8 this. Then 8 divided by 4 will give us 2. So this is what we now will be needed to draw the histogram. So we're going to be plotting the frequency density against the class boundary. So that we will do in the next slide. Now this is our graph that we'll be using to plot this histogram. Now in this case, now we are going. I extracted this from the table that we got in the previous slide. Since we are going to be using this to draw the histogram, we have the frequency density and we have the class boundaries. So frequency density will be on the y-axis and the class boundaries will be on the x-axis. Then you will need to label your axis, the y-axis and the x-axis. Now if I look at my frequency density, I can see that the gap between them is not too big. So the highest number here is 3.6 and the minimum here is 0.8. So and I have like 8 boxes here or more than that. So instead of that, I know that from here to here is 2 centimeters. Then from here to here is also another 2 centimeters. So I can use 4 centimeter to 1 unit for my y-axis. So that means I will have a 1 here, then another 4 centimeter I have 2, another 4 centimeter I have 3, another 4 centimeter I have 4, and I have 5 here. So that will make the histogram to be a little bit big. So then also on the y-axis, so on the x-axis, I'll put my class boundaries there. Since the value does not start from 0, so that means I'm not going to start from here. I'll put my 54.5 here, next one to 59.5 to 65.5 to 71.5 to 78.5 to 86.5 to 90.5. So with that now I've been able to label the axis of the graph. Then I can now start plotting, but before I plot, I would need to know what one line will be on the y-axis. So help me, since you're having decimal numbers here. So I have 2 centimeter to carry 1 unit, and in between the 2 cent, sorry, I have 4 centimeter rather to carry 1 unit, and in between the 4 centimeters, I have all these small lines. From here to here, we have 10. From here to here, we have another 10, making 20. So we have 20 lines in here. So all we need to do is that we need to divide 1 by 20. So that gives us what one line will carry, and that should give us 0.05. So that one line is 0.05. Then that means 2 lines will be 0.1. So 2 small line will be 0.1. That will help us to be able to locate all these values. Now the first one we need to plot is 3.6. So this is 3 here. So 2 lines is 0.1. That is 3.1, 3.2, 3.3, 3.4, 3.5. Then the next 2 lines 3.6. So that means I will draw a straight line on here to 3.6 here. So I will draw a straight line to 3.6 here, then draw a rectangle, draw another horizontal line here, then bring it down. So that give me the box or the block for the first one. Then the next one is a 0.8. So 0.8 is going to be, this is this line here is going to be 0.5. The next 2 lines 0.6, next 2 lines 0.7, next line 0.8. So that means it should be around somewhere here. So all I need is to draw my horizontal line. Oh, sorry, there's an error here. We want to go and do the 1.8. So this is a typographical error. So that's an oversight. This is 0.8. So it should be around here. Please correct that by yourself. 0.8 should be around here. 0.8 should be around here. So I don't know why that should be an oversight for my own hand. So 0.8 should be around here. So you draw a rectangle, an horizontal line here, then you bring it down. So it is not where I put here. This should be 1.8. So we want to go and do 1.8 instead of 0.8. So do the 0.8 by yourself. It should be around somewhere here, and you draw it down. So this is wrong now. Please correct that from your hand. The next one is 3.3. So this is 3 here. Then 3.3. That means we need like 6 line more, because 2 lines is 0.1. So we need like 6 small lines. So that means I'll be having 3.1, 3.2, 3.3. So I'll draw this straight line up. So when you draw it up, then you draw a horizontal line there, then you bring it down as well. So that gives us the next one. The next one is 3.1. So this is 3. Then 3.1, we need 2 more lines. So 2 more lines here. That gives us 3.1. So I'll draw an horizontal line there, then bring it down also. That'll give us that one. Then the next one is 3.4. This is still here for 3.4. I need more. I need 8 lines more. So 3.1, 0.2, 0.3, 0.4. So I'll draw an horizontal line there. Okay, oh, sorry, I will draw it up a little bit, draw an horizontal line, then break it down also. Then the last one is 2.0, which is here. 2.0, I'll draw an horizontal line here, then bring it down also. So this is the histogram, but the error is here now. Please correct that from your own hand. It is 1.8, is 0.8, not 1.8. We went to plot 1.8 instead of 0.8. So this is the histogram, but we need to you need to close this gap because the graph is not starting from the origin. So you need to draw a line like this. This is called a jagged line. So you need to draw this jagged line to tell us that the graph is not starting from the origin. So this is the histogram we have to prepare for question number 5. Question number 6 is from the probability. If 2 fair dice are thrown together twice, find probability of obtaining a product of 6 in the first row and a sum of 8 in the second row. So, like they told you, the question is from probability. When you throw 2 dice, together. So if I throw 2 dice together, then this will give us the total outcomes, or the sample space of throwing 2 dice at the same time. So this, I'm just replicating it so that you'll be able to, I replicated the diagram so that we'll be able to get from this one of the diagram the first thing we want us to get, and the second one can get whatever you want us to get for the second one can get from this chart as well. So but it doesn't matter that you can just use one of them to do the two, but I just use it so as to help us see clearly. Now let's go back. If 2 fair dice are thrown together, so if I throw 2 dice, I'm going to have this sample space. This is representing the first die, this is representing the second die. So if I throw them together, one die can show 1, another one can show 2, the first one can show 1, second one show 2. Sorry, what am I saying? The first die can show 1, the second one also will show 1. The first die can show 1, the second one will show 2. The first one can show 1, second one will show 3. Then the first one can show 1, the second one will show 4, and so on. So the first one can show 2, the second one will show 1. Both of them can show 2 and 2, 2. First one can show 2, the other one can show 3, and so on like that. That will give us from all the outcomes you can get when we throw 2 dice, whether together or one after the other, which is the 36 in number. So we have to find probability of obtaining a product of 6 in the first row. Product of 6 in the first row. Let's see. Product of 6. That means the two numbers that show when you multiply them together, when you multiply the two numbers that shows together, it's going to give us a 6. So that means this one can go. This one is favorable. Which one else? I think this one is favorable. 3 times 2 is 6. Favorable is here also. Then this one is also favorable. So that means that we have all these to be favorable out of all. Then also, and sum of 8 in the second row. Sum of 8. So you can do it here also, but I want to do it here. So as to, I don't want to merge everything together. So sum of 8. That means I mean this is favorable here. Sum of 8, sum of 8, sum of 8, sum of 8, sum of 8. So you could have done it on this table as well, but I want you to see clearly. So now that we have seen the favorable outcomes, so now we can now go back to our solution. So for the probability of a product of 6, that will be 4 out of 36. That will be 4 over 36, and that gives us 1 over 9. Then for the sum of 8, probability for sum of 8, that gives us a 1, 2, 0. That gives us 5 over 36. Then now we are now to find the probability of obtaining product of 6 in the first row and sum of 8 in the second row. So the probability of a product of 6 and sum of 8 will now be this multiplied by this, because and means times. So that means you have a 1 over 9 times 55 over 36. And if you multiply that, will give us a 5 over 324, which is solution for question number 6. Question number 7 is from the motion. It's from motion in a inextensible string. We are told that a light inextensible string passes over a smooth pulley and carries the masses of 4 kg and 3 kg as its ends. If the masses are released from rest, calculate their acceleration. So the first thing to do is to try to sketch the diagram to represent this question. So I have a pulley, so you can draw a circle to represent the smooth pulley. Then at the two end of it, we have these masses 4 and 3 hang, and we are having an inextensible string to hold them down. So I will draw a straight line here to represent the string. Then here I will put the first mass, which is represented 4 kg. Then I will not put the 4 because it is this mass is under influence of gravity. That will give us the weight of the mass of this the weight of this object, which is 4 kg in mass. So the weight will now be the 4 times the gravity. So that will give us a 4g. Then also I will attach another line here to help us locate the load for this the second load, which is of mass 3 kg, and the weight will be 3g as well. Then there will be tension in this string, so which is represented by T, and the tension in at both sides are equal, the same thing rather. So that means this mass, if this the masses are released, that means this will pull this one. So that means this one will go up, this one will come down like this. So from there, what can we do? We should be able to find the net force on this of this what's it called, this mass, and the net force of this one as well. So we know that force is equal to mass times acceleration. So to get the net force on this side, or this mass here, so that should be the weight minus the tension. So that should give us the net force on this side of this. So that should give us the weight, which is 4g, minus the tension on the string. So that will be the net force for this one, and that should be equal to mass times acceleration as well. And the mass is 4 kilograms, so that gives us 4g minus t equals to 4a. So that gives us equation 1. Then we also need to get the net force for this side as well, and that should be the tension minus the weight of this object, and that will give us t minus 3g equals to 3a as well. So that will give us equation 2. So you can now solve this equation 1 and 2 simultaneously to find the value of our a. So if we add these two equations together, we'll be able to eliminate a t, which is the tension. So add equation 1 and equation 2, that will give us 4g minus 3g, that give us a g. Then minus t plus t give us 0. So we'll be having g equals to 4a plus 3 will give us 7a. So we can divide to find our a acceleration. We have to find divide both side by 7. So we have a. So our g is 10. So I caught the question. We are given that the acceleration is due to gravity is 10. So g is 10. So we have 10 equals 7a. Then a will be equal to 10 over 7 meter per second square, which is the acceleration we have to find. Then also on question number 7b, you have to find their speed after 3 seconds. You have to find the speed of this after they release the masses. They have to find their speed after 3 seconds. So we can use one of the equation of the motion. In this case, v is equal to u plus at, since the masses start they started from rest, so that means initial velocity will be 0. So we have to find the final velocity knowing the acceleration, and we are given the time in 3 seconds. So if you substitute that into this, we'll be having v is equal to 0 plus 10 over 7 multiplied by 3. So that should give us a 30 over 7, which is a 4.29 meter per second for the speed. So that's the solution for question number 7. Question number 8 is from momentum, which is also from force. It's also from force. We are told that a force of F Newton acts on a body of mass 50 kilogram and changes its velocity from 30 meter per second to 40 meter per second in 6 seconds. We have to find the magnitude of the force. So we know that the mass here is when the mass multiply the velocity, that is momentum. So, and then when force multiply times as well, that's also momentum as well. So that means that the momentum could be equal to ft, which is also the momentum, could be equal to m into bracket change in velocity. So that means we'll be having ft is equals to mass into change in velocity. So ft is talking about momentum, and m also, m into bracket v minus is also changing a momentum as well. So with this, we'll be able to find the value of our f, since we know our time, which is 6 seconds. We know the initial velocity and the final velocity, and we know the mass of the body. So we can use that to find the force. So if you put that into this equation we have here, we are having f multiplied by 6, which is 6 seconds, equals to mass is 50 kilogram into final velocity is 40 minus initial velocity, which is 30. Then if you simplify for that, you'll be having 6f equals to 50 times 10. That should give us 6f equals to 500 divided by 6. Then the force will be 83.33 Newton. Then from there, we have to find the acceleration of the body, which you can use the relation between the force, mass, and acceleration, which is force is mass times acceleration. Then we have to find acceleration, that will be force divided by mass. And we know the force, which is what we have gotten here, and we know the mass, which is the 50 kilogram. If you put that into this, we'll be having this divided, you'll be having 1.67 meter per second squares as the unit of acceleration. Then also we have to find the distance covered in 9 seconds when the initial velocity is 30 meter per second. So using that g is 10 meter per second squared. So you can also use one of the equation of the motion, which is distance equals to ut plus half at squared. We are looking for the distance, which is x. So the initial velocity is 30, and then we have time to be 9, and acceleration is what we have gotten here before. If you put that into this formula, we have 30 times 9 plus half times 1.67 times 9 squared. Then if you simplify this, you'll be having 270 plus 67.5, and that will give us 337.5 meters as the distance covered. So that's the solution for question number 8. Question number 9 is from the integration. We are given that this definite integral 2x squared minus x minus 3 dx from the boundary is being from m is ranging from m to minus 1 equals to minus 9 over 2, where m is the integer. We have to find the value of m. So what can we do? We need to integrate this function. So we'll be having 2x squared minus x minus 3 dx. When you integrate it and you pull this boundary, it's going to be equal to minus 9 over 2. So let's integrate this function. So if you integrate my 2x squared, that should give us a 2x cubed over 3. So that'll give us a 2x cubed over 3. Then integrate minus x, that'll give us a minus s squared over 2. If you integrate minus 3, that'll give us a minus 3s. Then you plus constant c. You now put the boundary, which is m, and to minus 1. And that gives us a minus 9 over 2. Then from there, you need to pull this boundary into this. So wherever you see x, you put m. So that gives us the first one minus whatever you see m, you put wherever you see x, you put minus 1 also, equals to minus 9 over 2. If you do that, you'll be having this. So you'll be having 2 into m cubed over 3 minus m squared over 2 minus 3m plus c minus open bracket again, you put minus 1 into whatever you see x. You have 2 into minus 1 cubed over 3 into minus 1 over minus squared over 2 minus 3 into minus 1 plus c equals to minus 9 over 2. Then from there, we can simplify further. So minus 1 cube give us minus 1. Minus 1 square will give us 1. Then this one will give us an addition here also. If you simplify that, so we see how the same thing as this side, minus. So we have a minus 2 over 3. Yes, minus 1 over 2. Then plus 3 plus c equals to minus 1 over 2. Then this minus, we will open this bracket. If you do that, you'll be having plus 2 over 3 plus half minus 3. Then minus c. So minus c plus c will give us 0. That one will vanish, equals to minus 9 over 2. Then from there, we can find the LCM of denominator and multiply through. So the LCM should be 6. You can multiply through by 6 to clear the denominators. Or what did I do? Okay, that's what I did. So multiply through by 6. So if I multiply this one by 6, 3 will cancel 6. That gives us 2. 2 times 2 gives us 4. We have 4m cubed. Multiply this one by 6. That gives us 2. We cancel 6. That gives us 3. We have minus 3m squared. Multiply this one by 6. That gives us a minus 18m. Multiply this one by 6. That will give us 4. Multiply this one by 6. That will give us 3. Multiply this one by 6. That will give minus 18. Multiply this one by 6. That will give us minus 6 times 9. That will give us minus 3 times 9 give us a minus 27 rather. From there, you can collect like times by bringing this minus 27 here. So we'll be having 4m cubed minus 3m squared minus 18m plus 16 equals 0. So that gives us a cubic equation to solve to be able to find the value of our m in this case. So we know that this can be the first thing to do is to find the first factor of this equation using trial and error method. So if I use trial and error method, I'll be able to get the first factor of this equation, and that will enable me to be able to know other factors. So what can we do? I use the trial and error method to find the first factor, and when m is equals to 2, if you put that into this equation, it's going to give us 0. So if you put that into it, it gives us a 0 and simplify it. So that means m minus 2 is a factor. And but because say we should find the you have to find the value of m, not values. Of course, we know that this equation is going to give us we are going to get the answer for this cubic equation. Because say we should find value of m, not values. If we say you should find value, so and we know that our m is already 2 here, so why do we need to go further? We don't need to go further since they didn't say values. So that means they just want us to find one value of m. So and our m is already 2 here. See, after using the trial and error method, which shows that our m minus 2 is a factor, so our m is 2. So therefore, our m is the answer is going to be m is going to be 2. And that solved the question for us. We don't need to look for other factors or other values of m, since they said we should find the value of m, not values. Then question number 9b is from a logarithm and the linear equation. You have to solve them simultaneously. Solve 2 into log s base 3 minus 1 equals to log s base 3, and y is equal to sod s plus 1 simultaneously. So we can start with the logarithm. You are having 2 log s base 3 minus 2 log s base 3. Okay, what did I do? I expand this bracket. 2 can multiply what you have in the bracket, so you'll be having this. 2 multiply this, you have this. 2 multiplied by minus 1, you have minus 2. Then from there we can collect like times. I can bring this log into this place. I will take 2 to this side. We'll be having this 2 log s base 3 minus log s base 3 equals to 2. So we can subtract this because we are having 2 of this minus 1 of this. So 2 of this minus 1 of this, that will give us log s base 3 equals to 2. So, and if you understand what this literally means, log s base 3 equals to 2, it means I can raise 3 twice to get x. So if you want to understand the logarithm very well, you can check my YouTube channel where there's a video I make on logarithm and indices. That video will really help you understand the meaning of logarithm, and doing all this kind of thing will not be a problem. So check this video and you will never remain the same understanding logarithm. So log s base 3 equals to 2 means I can raise 3 twice to get x. So that means our s will be equal to 3 raised to power 2, and that means s will be equal to 9. Now that we know the value of our s to be 9, you can use that to find our y here. Our y is equal to sod s plus 1. So y will be equal to sod 9 plus 1. Since our s is already 9, we already know the value of our x. So what is sod 9? That will give us 3 plus 1. And the y will be equal to 4. So therefore our s is 9, our y is 4. Which is question number 9. Question number 10 is from the sequence and series, in this case exponential sequence, which is a GP. We are given that 8 combination x, 7 combination x, and 7/6 into 6 combination x form first 3 consecutive terms of an exponential sequence GP. Find the value of x first. So we are given this these 3 consecutive terms of a GP, but the question is in terms of combination. What do? We can simplify. 8 combination s will give us 8 factorial over 8 minus s factorial s factorial, comma, then 7 combination s will give us 7 factorial over 7 minus s factorial s factorial, comma, then 7 into 7/6 into 6 combination s will give us 6 factorial over 6 minus s factorial s factorial. So these are the three consecutive terms of the GP that we have been able to simplify. Now from there, since this is a GP, that means it's supposed to have common ratio. There should be common ratio between these terms. So that means, how do you find a common ratio of a GP? That means the second term divided by the first term should be equal to the third term divided by the second term. So that means this second term, which is this, divided by the first term, which is this, should be equal to the third term, which is this, divided by the second term, which is called common ratio. So with this, we'll be able to use that to find the value of our x. So what can we do from here? This one can be changed to multiplication by this one going up, this one coming down. Likewise here as well. So that means I can do is to be 7 factorial over 7 minus s factorial times 8 minus s factorial over 8 factorial equals to this, multiplied by this. Also we go up and down, you have this as well. So from there also, now what can we do? We can expand this 8 minus s factorial, we can expand it so as to give us a 7 minus s factorial. So that means if I remove 1 from this, I'll be having 7 minus x. So that means this can now becomes this times this will becomes 8 minus x into 7 minus s factorial equals to the same thing we can do here also by subtracting 1 from here to give us 6 minus s factorial, so that this can cancel this as well. So if you do that, what can we do? So 7, okay, also we can also expand the 8 factorial also to give us 8 times 7 factorial, so that you can deal with this as well. Then also we can also expand 7 factorial to give us 7 times 6 factorial to be able to take care of this as well. So if you do that, so what 7 minus s factorial will cancel this one, s factorial will cancel s factorial, 7 factorial will cancel 7 factorial. That means you are left with 8 minus x over 8 here equals to 6 factorial will take care of 6 factorial, 6 minus s factorial will take care of 6 minus s factorial, but s factorial will take care of s factorial. So that means we are left with Okay, 7 can take care of 7 here, so we are left with 7 minus x over 6. So that's what we have left here. So after simplifying it one after the other, from there now, so which also represent our common ratio, because this is the left hand side, this is the right hand side, so they also represent the common ratio if you look at it critically. Then what can we do? We can cross multiply from there. Since we multiply this, it multiply this, we have this. If you expand the bracket, we have 48 minus 6x equals to 56 minus 8x. You can take the like times, so that will give us if I bring minus 8x, that will give us a minus 6x plus 8, that will give us 2x equals to 56 minus 40, that give us 8. Divide both sides by 2, s will be equals to 4. So that's all the value of our s for us to be 4. Then b part of it, you have to find the common ratio. You have to find the common ratio. So I can use any of this to find the common ratio. Either I use 8 minus s over 8, or I can use 7 minus s over 6, because they represent the common ratio. So common ratio, yeah, I said 8 minus s over 8. So that means our s is 4. You can put that here. That gives us 8 minus 4 over 8. That should give us 4 over 8, and that gives us a half. So the common ratio is half. Then also we have to there's another question where there's part C of this. So we have to find the sum of terms there, and we need to know the first term, which is our a, in order to do that. So let's first find our first term here. So the first term here is this, which is 8 factorial over 8 minus s factorial, which is our first term. So if you put our value of our x there, you'll be having 8 factorial over s minus 8 minus 4 factorial, 4 factorial. So if you simplify that further, that gives us 8 factorial over 4 factorial, 4 factorial. So you can expand this 8 factorial, can expand this so as to take care of 4 factorial here. Like 8 times 7 times 6 times 4 times 4 factorial over 4 factorial, 4 factorial. 4 factorial will take care of 4 factorial. So that means you'll be having 8 times 7 times 6 times 5 over 4 factorial. And 4 factorial is 24. So if you divide the numerator by 24, that gives us 70 to be the first term. So you have to find the sum of the first 10 term of the sequence. Sum of the first 10 term of the sequence. And we know that when it comes to GP, we have 3 formulas for summing terms together. So there is sum of term when the common ratio is less than 1. The sum of term when the common ratio is greater than 1, and there is sum to infinity. So, but in this case, our common ratio, which is r, is 1 over 2, and that is less than 1. So that means solving this, we'll be using the formula for summing terms together when r is less than 1, which is this you have been on the screen right now. So we are summing 10 terms together, so that means our n will be 10. We have sum of 10 equals, so the first time is 70. That's what we did, we got before this slide, into 1 minus our common ratio is 1 over 2 raised to power 10 over 1 minus 2. So over 1 minus 1 over 2 rather. Then if you simplify that further, we'll be having 70 into 1 minus 1 raised to power 10 is 1 over 2 raised to power 10 is 1024. 1 minus half will give us half. Then from there, you'll be having 70 into, if you find the LCM of this, 1 minus 1 over 1024, that gives us a 1 over 123 over 1023 over 1024. Then divided, which is the division by half. We can now change this one to times. So that gives us 70 times 1023 over 1024 times 2 over 1. So we can now simplify by reducing this, and that should give us 139.86 as the sum of the first 10 terms of the sequence. So that's all that question for us. Question number 11 is from Surd. You have to express this minus this in terms of p plus q, Surd 7, where p and q are real numbers. So we have to solve this question, but if you look at the question critically, we are having this bracket raised to power 2 minus this bracket raised to power 2. this look like difference of two squares. So if you look at it physically, it look like difference of two squares. So that means you can apply difference of two squares to solve it, or if you like, you can expand this bracket in two places minus expand this bracket in two places as well. Any way you want it, you will get the same thing at the end of the day. But I apply difference of two square here, so that means I'll be having this bracket plus this bracket in one bracket minus multiplied by this bracket minus this bracket as well. So that means I'll be having, okay, this is the question. I apply the difference of two squares. I'll be having this plus this in one bracket multiplied by this minus this in another bracket. So this I've applied difference of two squares. So from there, we will now find the LCM to add this together. We find the SML to subtract this as well. So what's the STM of 4 minus 7 and 4 plus 7? So that should be 4 minus 7 into 4 plus 7, which is also a difference of two squares, which can be written as 4 squared minus 7 squared. So to add this fraction together, so that means I'll be having this as the LCM of this and this. Then we can now go this in this, that give us a 4 plus 7. That will multiply the numerator, that will give us what you're having here. Then plus this in this, you'll be having 4 minus 7 left. That will multiply the numerator, we'll be having this left as well. So the same thing will be performed here as well. We'll find the LCM of the numerators, of the denominator rather. That will give us this as well. Then this in this, that means we are having this left. Then multiply this, you have this. Then minus, we have a this in this, we'll be having a 4 minus 7 left. To multiply numerator, that means you're having this as well. Then from there, what can we do? We can now expand the brackets. So if you expand the brackets, what do we have? 4 times 4 give us 16. 4 times 7 give us 4/7. So 7 times 4 give us 4/7. Then 7 times 7 give us 7. Then plus 4 times 4 give us 16. 4 times minus 7 give us minus 4/7. Minus 7 times 4 give us a minus 4/7. Then minus 7 times minus 7 give us a plus 7 over, this is a difference of two squares. That means I can write as 4 squared minus 7 squared. The same thing will be done here. We expand the brackets. 6 times 6 is 4 times 4 is 16. 4 times 7 will give us a 4/7. So 7 times 4 give us a 4/7. So 7 times 7 will give us a 7. Then minus open brackets. 4 times 4 is 16. 4 times minus 7 will give us a minus 4/7. Minus 7 times 4 is minus 4/7. Minus 7 times minus 7 will give us a plus 7 over, the denominator is a difference of two squared, that gives us a 4 squared minus a 7 squared. You can collect the like terms from here. That give us 16 plus 16 give us 32. Okay, I didn't do that yet. Yeah, okay, we'll do it. Let's see. Okay, we collected like times 4/7 plus 4/7 give us 8/7. So here also minus 4/7 minus 4/7 give us a minus 8/7. The same thing is done here as well. Okay, then from there, this will neutralize this. 8/7 minus 8/7 will give us 0. So we'll be having 16 plus 16, that will give us 32. 32 plus 7 plus 7, that will give us 46. Then 4 square is 16. So 7 square is 7. That will give us 16 minus 7, that will give us 9. Then let's go here. We have here 16 plus 7, that gives us 23. Plus 8/7 minus open bracket 16 plus 17 will give 16 plus 7 give us 23 minus 8/7 over 9. Then this minus will open this bracket here also. We will be having minus 23 then plus 8/7. So minus 23 plus minus 23 plus 23 minus 23 will give us a 0. Then 8/7 plus 8/7, that will give us a 16/7 over 9. Then from there, this can multiply out, and this will multiply out. That will give us 736/7 over 81. But the question says we should express it in this form. So that means that's why we added 0 plus, so that it can look like this. Since when you multiply this out, that will give us this. So we need to express it in this form. So that's why we had we'll put 0 plus, so that it look like this pattern. So, and that is the solution for question number 11. And if you want to know Surd very well, you can check my YouTube channel. There is a video I made on Surd, which is an extended video on Surd. It will really help you understand how to deal with this kind of Surd. Question number 11b is from function also. Is from function. We are told that the two functions f and g are defined on the set of real number by f of x is equals to this and g of x is equals to this, where your s is not equals to plus or minus 2. So 2, you have to find the domain of g. You have to find g of f of x. Now we have to find the domain of g. Domain of g has to be now the value of the x in inequality form. So the range of values of x, that's what they want us to find in that case. So our f of s is this. You have to find the domain of f. So that means this will be greater than or equals to 0. So we'll be having the f of s will be greater than or equals to 0. Then from here you'll be able to find the domain of f. And then the first thing to do is to remove the square root. How do we remove the square root? If by squaring the both sides. If I square both sides, then this square root will leave. So I will square this and I will square 0. So that will give us a 16 minus s squared over s squared plus 4 greater than or equals to 0. From there you can cross multiply. This will multiply 0, that gives us 0. So you'll be having 16 minus s squared greater than or equals to 0. Then from there you can express this one as a difference of 2 squares. That will give us a 4 raised to the power 2 minus s squared greater than or equals to 0. So you'll be having this as well. You have 4 plus s into s minus 4 minus s greater than or equals to 0, which can be written as 4 plus s greater than or equals to 0, or 4 minus s greater than or equals to 0. So if you simplify this, that gives us s is greater than or equals to minus 4, or s is less than or equals to 4. If you combine, that should give us minus 4 less than or equals to x less than or equals to 4. Then a domain now becomes s and s elements, so that s belongs to set of real number. Then our s is between minus 4 and 4. So this is the domain of f of s that I want us to find for question number 11b, Roman figure 1. Then Roman figure 2, we have to find g of f of x. So that means we are putting our f of s into g of x. So what does that mean? Whenever we see x in this g of x, we'll replace it by this f of x. So that's what it means. So that means in the g of x, I have s squared. So this s squared, that s squared will be replaced by this square root of 16 minus s squared over s squared plus 4. So that will give us the square of this minus 4 over 8 minus the square of this as well. So that means we'll be having this now. So we have been able to put f of s into g of x. I hope you understand this concept. Now, if you move further from there, what do we do? The square will take care of the square root here, and the square also will take care of square root here also. So we'll be having 16 minus s squared over s squared plus 4 minus 4 over 8 minus the square will take care of the square root also. We'll be having this as well. So we need to simplify the numerator here by finding the LCM, and the same thing will be done here also. Find the LCM, and the LCM here is s squared plus 4. The same thing is here as well. If you simplify that further, this we are having here is representing this. The LCM is s squared plus 4, which is here. Then s squared plus 4 in this, that give us 1. 1 times this will give us 16 minus s squared. Then minus 1 in s squared plus 4, that will give us s squared plus 4 times minus 4, that will give us what we are having here. Then this divided is this one. Then we also perform the same thing here. Find the LCM of 1 and s squared plus 4, that gives us s squared plus 4. 1 in s squared plus 4, that gives us s squared plus 4 times 8. That give what you're having here. Then minus, then x squared plus 4 in x squared plus 4 give us 1. 1 times this, we have minus the. So from there, what do? We expand the bracket here. We'll be having a 16 minus s squared minus 4, or open the bracket, we have a minus 4s squared minus 4 times 4 gives us minus 16 over this, divided by, you have expand this bracket, we have a 8s squared plus 32, expand the bracket, that gives us minus 16 plus s squared over this. Then from there we can collect the like terms here. 16 minus 16 will give us 0, minus s squared minus 4s squared will give us a minus 5s squared. So you have minus 5s squared over s squared plus 4, divided by, here also we have a 8s squared plus s squared, that gives us 9s squared. Then 32 minus 16 gives us a 16 over s squared plus 4. Then you can now change this one to times. This one will go up, this one will come down. So we'll be having a minus 5s squared over s squared plus 4 times s squared plus 4 over 9s squared plus 16. This will cancel out this. So that gives us this single fraction as our answer. Question number 12 is from the statistics. You are told that if the mean and the standard deviation of the number x, 2.5, 4, y, and 7 are 4 and the square root of 31 over 10, respectively, you have to find the value of x and y where s is less than y. So we are having this on group data, x, 2.54, y, and 7. We are having these 5 data, and we are told that their mean is 4 and their standard deviation is so 31 over 10. We have to use that to find the value of x and y. So let's start with the mean. So to find mean of this data, all you need to do is to add them together and divide it by number of data there, and that will be equal to the value of mean, which is 4. So mean is called s bar. So how do we find mean? Is by adding the data together divided by number of data, which is 5. We have been given the value of the mean, which is 4. So that may be having 4 is equals to, if you collect like times here, 2.5 plus 4 plus 7 give us 13.5 plus s plus y over 5. From there we can cross multiply. So we'll be having 5 will multiply 4. That will give us 13.5 plus s plus y equals to 20. Then collect like times 13.5 will come here. We have s plus y equals to this. S plus y will be equal to 6.5. We can call that equation 1. Then also using standard deviation. Standard deviation of an ungrouped data is calculated by square root of summation s minus s bar over n. So s bar is the mean that we are given, which is 4. Our x are the data we have here. Our n is the number of data, which is 5. So we can compute this also in the tabular form. So this is our x. Our s here is represented by the data given to us. We have x, 2.54, y, and 7. Then we cannot compute s minus s bar, knowing that our s bar is mean. We already know the value of our mean, which is 4. So that means we'll be removing all this value of x from mean. So that means we'll be having s minus s bar. That will be x, which is this one, minus mean, which is 4. So you have s minus 4. Then the next one will be 2.5 minus 4. That will give us a minus 1.5. 4 minus 4 give us 0. Y minus 4 give us a y minus 4. 7 minus 4 give us 3. Then having gotten s minus s bar, we need to square it also. We'll be having s minus s bar squared. So that means we need to square s plus s minus 4, you have c squared. Then minus 1.5 squared will give us 2.25 rather. 0 squared is 0. Y minus 4 squared, you have y minus 4 squared. 3 squared is what? 9. Then after doing that, we need to sum them together, summation. So we sum this together, and when you sum it together, that gives us the s minus 4 squared plus y minus 4 squared. 2.25 plus 9 gives us 11.25. So we can now put this into this formula. Now that we know this, we can put it into this formula. What would that be? We know the value of the standard deviation, that is should be sort 31 over 10. So we'll be having sort 31 over 10 equals to square root of summation of s minus s bar squared, which is this. We have square root of this over our n. Our n is 5. So we can now go back and simplify this one further in the next slide. So we are having this in the previous slide, which we need to simplify further. What do? We need to get rid of the square roots at both sides. That means we need to square both sides to get rid of the square roots. So if I square this and I square this, I'll be having a 31 over 10 equals to what you're having inside the bracket, inside the square root rather. Then after that, what do? We can cross multiply from there. 5 will multiply 31 and 10 will multiply everything here. So if you do that, 5 times 31 gives us 155. Then 10 will multiply this as well. So we'll be having 10 into bracket. You expand s minus 4 squared. So you'll be having s minus 4 in two places. Then you expand and collect like that. You'll be having s squared minus 8s plus 16. The same thing for y minus 4 squared also. That will be y minus 4 into bracket y minus 4. Expand it and collect like times. You'll be having y squared minus 8y plus 16 also. Then plus 11.25, which is multiplying by 10 here after cross multiplying. Then from there, what can we do? We can add 16 plus 11.25. So that will give us 10 into s squared minus 8s plus y squared minus 8y. When you add this plus 16 plus 11, that will give us 43.25. From there, you can now expand this bracket by multiplying by 10. You'll be having 155 equals to 10s squared minus 80x minus 10y squared minus 80y plus 432.5. From then now, what can we do? We can collect like times. So we can bring this 115 to this side so as to remove it from that. That gives us 10s squared minus 8x plus 10y squared minus 10y. So 432.5 minus 155 will give us 277.5 equals to 0, which is equation 2. Now that we have this equation 2 in terms of x and y as well, all we need to do is to substitute equation 1 into equation 2. So we remember that from equation 1 we have our s plus y to be equal to 6.5. So you can make s sort of the formula so that you can put that into this equation here. So s will be equal to 6.5 minus y. You can call it down equation 3. You can now put equation 3 into equation 2. So that means anywhere I see x here, I'll put 6.5 minus y. So that makes this equation to be 10 into bracket 6.5 minus y squared minus 80 into 6.5 minus y plus 10y squared minus 80y plus 227.5 equals 0. So that means I will need to expand this bracket in two places as well. So if you do that, you'll be having 42.25 minus 13y plus y squared. Then minus 80 will expand this bracket as well. We'll be having minus 520 plus 80y plus 10y squared minus 80y plus 277.5 equals 0. Then also here 10 will expand this bracket. 10 will open the bracket here. You'll be having a 422.5 minus 130y plus 10y squared. Then minus 520. Then 80y minus 80y will give us 0. Then plus 10y squared plus 227.5 equals 0. From there, we need to take the like time because we're having everything in terms of y now. We have 10y plus 10y, sorry, 10y squared plus 10y squared give us a 20y squared. Then we have a minus 130y. Then we have 422.5 minus 520 plus 277.5. That gives us a 180 equals 0. So I think 10 is common. You can divide through by 10 so as to reduce this quadratic equation. That gives us a 2y squared minus 13y plus 18 equals 0. So we can now solve this equation using method of a quadratic equation for solving quadratic equation. And this can be solved using factorization method. So 2 will multiply 18 first, that gives us 36. Then two numbers can multiply together to give us 36. And when you add them together, it will give us a minus 13. That should be minus 9 minus 4. Minus 9 minus 4 will replace minus 13y here. That will give us a minus 2y. That gives us 2y squared minus 4y minus 9y plus 18 equals 0. We can now factorize here. 2y is here. 2y is common here, so we have 2y into y minus 2. then minus 9 is common here. You have minus 9 into y minus 2 equals 0. So that means we'll be having 2y minus 9 into y minus 2 equals 0. So each of the brackets will be equal to 0 also. So from there we'll be able to find our y. So y will be equal to 9 over 2, or y will be equal to 2. So that will be the value of our y. So also we need to find the value of our x, knowing the value of our y now. So from equation 3 here, we'll be able to find the value of our y, so the value of our x rather. So when our y is 4.5, we have our s to be 6.5 minus y. So our y is 4.5, put it there. We'll be having 6.5 minus 4.5, that will give us a 2. Then when our y is equal to 2, also we need to find the value of our x. So that means s will be equal to 6.5 minus 2, that gives us a 4.5. Therefore, our answer, when our s is 2, our y is 4.5, and when our y is 4. Our s is 4.5, our y is 2. So that's the solution to that question. Question number 13 is from the probability in conjunction with a combination. Probability in conjunction with a combination. So we are told that an association is made up of 10 journalists and 9 engineers. If a committee of 4 members is to be formed from the association, find probability that it will consist of at least 2 engineers. So we are having 10 journalists, 9 engineers, and 4 committee of 4 members is to be formed. So that is where combination comes in. Then we have to find the probability at least 2 engineers will be in the committee. So what do we have? Probability of at least 2 engineers. So that means S here is representing number of engineers. So at least means it could be 2 or more than 2 engineers. So that means you have to first of all find probability that it is 2 engineers exactly, or probability that it is 3 engineers, and probability that it is 4 engineers. Then we should know that the probability of an experiment or event is favorable outcome over total outcome. So now, how do we find the probability of at least 2 engineers? So to find probability of exactly 2, that should be that means you're having 2 engineers exactly here. So that means we'll be having 2 journalists, 2 engineers, since 4 members, 4 committees are to be formed. So that means I'll be having from the 10 journalists, I'll be having 10 combination 2 multiplied by 9 combination 2 as well for this exactly 2 engineers. Then for 3 engineers now, that means 3 engineers will be in the member. So that means we'll be having 1 journalist left. So we have 10 combination 1 multiplied by 9 combination 3. Or 4 engineers now, that means no journalist will be picked. So that means I'll be having 10 combination 0 multiplied by 9 combination 4 over, that's for favorable outcome. Then over total outcome will be the addition of the engineer and the journalist. That will be 10 plus 9, that will be your 19 combination, the 4 of them that were to be picked. So that means I'll be having something like this. You can see, look, this is what I just explained now with my mouth. So everything at the top here is talking about the favorable outcomes, then over total outcome, which is 19 combination 4. Then from there, if you use your calculator at this point, 10 combination 2 will give us a 45, multiplied by 9 combination 2 is 36, plus don't forget that or that we are having here, that we have options, that way they are having plus here. Or in probability means plus. 10 combination 1 is 10, then 9 combination 3 is 84, 10 combination 0 is 1, 9 combination 4 is 126, then 19 combination 4 gives us a 3876. If you simplify this numerator further, you'll be having 1620 plus 840 plus 126 over this. Simplify further, that will give us 2586 over 3876. If you reduce that, that will give us a 0.667 as the probability of the committing consisting of at least of 2 engineers. Then for B, find probability that it will consist of 75% of journalists. So 75% of journalists is the second one now for B. 75% of journalists, since we are having 4 members, we need to find 75% of the 4 members. 75% of 4 members will be 75 over 100 times 4. That will give us a 3. So that means we'll be having 3 journalists in the committee. So if you have 3 journalists in the committee, that means we'll be having you'll be left with 1 member who should be engineer. So that means you'll be having the probability of exactly 3 journalists now. S representing journalists in this case now. So 3 journalists now. So that will give us we're going to be picking 3 journalists from 10 journalists. That will be 10 combination 3 multiplied by, we are having 1 member which is going to be from the engineer. So we'll be having 9 combination 1 over total outcome, which is B 19 combination 4. If you simplify this further, you'll be having 10 combination 3 is 120 times 9 combination 1 is 9 over 90 combination 4 is 3,876. If you multiply how that give us 1080 over 3,876, and that give us 0.278. So the next question will be solved from the next slide, which is talking about the probability that it will consist of odd number of engineers. Odd numbers of engineers. So don't forget that we are having 4 members, but now they are talking about odd members of engineers now. That means you are looking for odd number from a 0 to 4, and that should give us a 1 and a 3. So that means we'll be having the probability of odd number of engineers will be probability of exactly 1 or probability of exactly 3, because these are the odd numbers between 0 and 4, since you are picking 4 members. So definitely you are having for this one we are having 1 engineer, so that we'll be having 3 journalists left, and here we are having 3 engineers, so we'll be having 1 journalist left. So if you put that into this formula, you'll be having 10 combination 3, which is representing 10 journalists, picking 3 out of them. Then we are having 1 engineer here, so that'll be 9 engineers picking 1 plus, which is all. We are having 3 engineers here, that means we left 1 journalist, that will be 10 combination 1 multiplied by the 9 combination 3, which is representing the engineers over total outcome, which is 19 combination 4. And if you simplify this further, that will give us 120 times 9 plus 10 multiplied by 84 over this. Simplify further, that gives us 1020 over this. That gives us 0.495 for question number for that question. Then question number 14 is from vector. We are told that the 5 forces acting on the particle are represented by these vectors, where P, Q belongs to real number. We have to find, so if the particle is in equilibrium, we have to find the value of P and Q. So we are given this vector in x, I and j dimension. So the first thing what we can do is that we can change this vector to column vector. So if you change them to column vector, then we'll be able to add when since they are in the equilibrium position, that means when we add them together, it will give us 0. So if I change this each of them to column vector, that give us a 2, 3 here. For the next one, I'll give us a 4, 4 minus 7. I'll give us a minus 5 and 8. I'll change this 1, 1. Then it goes P, Q. Since they are in equilibrium, that means if I add all these column vectors together, it should give me 0. So if I add them together, give me 0. At this point, I should be able to add this together. We have 2 plus 4, that is 6, minus 5, that gives us a 1. 1 plus 1 is 2, then plus P. So we'll be having 2. I'll be having 2 here. Then 3 minus 7 is minus 4. Minus 4 plus 8 is 4, plus 1 that gives us 5. Then plus this column vector for P. So our aim is to find the value of P, so which is P and Q, which is represented by this column vector. So I can collect the light and bring this one here. I'll be having P, Q equals to minus 2, 5 here. And we know that this minus is a scalar. So it will multiply this element in this column vector. So that will give us this as well. Then that means P will be equal to -2 and Q will be equal to -5. So that's all the question number 14A for us. Question number 14B is still on vector as well. We are told that WXYZ is a parallelogram whose vertices are this. So we have to find the value of M and N. Then we have to find the unit vector in the direction of X, Y. So we are having a parallelogram and the vertices of the parallelogram is a W, X, Y, Z. So if I put the vertex here in coordinate form, I have a, okay, I know that the parallelogram, the two sides will be parallel and equal. So this will be parallel and equal to this as well. So if I put the vertices here, I have this for here, Y, and I have Z. So we have to find the value of M and N. Now, what can we do? We can also change this coordinate to column vector as well. And we should know that in a parallelogram, opposite sides are parallel. So that means the distance between of this, the distance xy should be equal to distance wz. So I can change that to a column vector as well. Then so change this each of them to column vector. Then when I find the distance between this and this should be equal to the distance between this and this as well. So that means this minus this should be equal to this minus this as well. So that means I'll be having I change this one to column vector, which is 2 4 minus this as well. Then it should be equal to this, which is this, minus this as well, after changing each of them to column vector. So having done that, if you now subtract 2 minus minus 1 will give us 3. Then 4 minus 1 will give us 3. So we'll be having 3 here. Then we have 5 minus m will give us 5 minus m. Then give us a minus 7, minus 7 minus m give us minus 7 minus n. So this is a column vector equals a column vector. So that means this should be equal to 3 and this should be equal to 3 as well. So we'll be having 5 minus, sorry, you're having 3 equals to 5 minus m. From here, you'll be able to find your m by collecting like times. So m will be equals to 5 minus 3. Then m will be equals to 2. Then also 3 will be equals to minus 7 minus n as well. So also we'll be able to find our n to be equals to minus 7 minus 3. That gives us minus 10. So our n is minus 10. Our m is 2. Then so equation for Roman figure 2, but to find the unit vector or in the direction of x, y. And we know that to find unit vector of a vector is the vector divided by the magnitude or the modulus of the vector. Then to find the unit vector, we will need the vector itself, and the vector itself is 3 and 3. So the vector x y from here is that vector xy, that should be this minus this, which is what you're having here. Then after changing them to column vector first, then we already know the value of our m and n, which is what you pull it here. When you subtract 5 minus 2 give us 3 and n. So we already know it. Even from here we are because the subtraction of the distance from this and this is equal to from here to here. So if from here to here give us 3 3, so that means this also will give us 3 3. So which is what we have confirmed there, but that's not the issue. So we have been able to find the column vector of xy, which you can change back to a normal vector. So, and you know that to find unit vector, we have the vector divided by the absolute values of the vector, the modulus of it. So, and the vector will be 3i minus 3 plus 3j over the magnitude of it, or the absolute values of it, which is be 3i square plus 3j square. So, oh sorry, square root of 3i square plus 3j square. So we know that I times I will give us 1. That's why we did not put 1 again. And j times j will give us 1. That's why we will not put j. So if we simplify this further, that will give us 3i plus 3j over 3 square is 9 plus 9, that gives us surd 18. And if you simplify surd 18, that gives us 3 surd 2. So you have 3i plus 3j over 3 surd 2. Then 3 is common at the numerator, you can factorize 3. And that 3 will cancel out 3 under, so that we're having I plus j over surd 2. So you are left with I plus j over surd 2. And we know that when it comes to surd, we know that this fraction, the denominator is in surd form, we need to rationalize it. So that means the surd 2 will multiply up and down. So we'll be having surd 2 into I plus j over 2, which is the solution for question number 14b. Question number 15, which is the last question, is from motion. We are told that an object is thrown vertically upward from the top of a building 20 meters high. If the object passes the point it was thrown after 4 seconds on its way down, find the velocity at which the object was thrown. So that's the first question we have to find. We have to find velocity at which the object was thrown. Now an object was thrown upward, and it also passes the point where it was thrown. That means it does not have an horizontal distance. So that means our s will be equal to 0 in that case. So s will be equal to 0. The time t is equal to 4 seconds, and our acceleration due to gravity will be negative since it was thrown upward. It is against gravity. So if you remember some equation of the motion that we can use to find our velocity, which is u, then our s is 0. You can put that into this equation. So that means you'll be having our 0 equals to 4, which is t, and u plus half our g is negative 10 plus 4 squared. If you simplify that for that 2, we go in minus 10, that gives us minus 5, and this is 16. So that will give us 0 equals to 4u minus 5 times 16. That should give us 0 equals to 4u minus 80. Can collect light times here, that gives us a 4 equals to 80 divided both sides by 4. U will be 20 meters per second, which is the velocity at which the object was thrown. B part of it was we have to find the time taken for when the object is 10 meters above the level it was thrown. So we are looking for time when the height h is 10 meters. So we have h to be 10 meters between the height that it was thrown. Then initial velocity is what we got in here is 20 meters per second. Then acceleration due to gravity will be negative as well. We are looking for time. If you remember some equation of motion that we can use as well, it's still the same thing we can use. So in this case, we are now having the distance along the straight line. We are having the height now given to be 10 meters as we have been given. So if you put that into this formula, and we are looking for time, don't forget. So we'll be having a 10 equals to 20, which is our initial velocity, multiplied by t plus half into minus 10 t squared. Then from there 2 can go in minus 10, that will give us a 10 equals to 20t minus 5t squared. Then from there 5 is common, so we can divide through by 5. That will give us a 2 equals to 4t minus t squared. Then from there you can collect light times to make it a complete quadratic equation. So if you rearrange it, you have a t squared minus 4t plus 2 equals to 0. So this is a quadratic equation now that we can solve to find the value of our t in this case. But this cannot be solved using factorization method. So we can use any other method that you will or you know. So in this case, I use the formula method. Our a is 1, our b is minus 4, our c is 2. So if I use formula method, that will be t is equals to minus b plus or minus square root of b squared minus 4ac over 2a. So if you pull your values into this, you'll be having this as well. If you simplify further because of our time, if you open the bracket, you have 4 plus or minus 4 minus 4 squared is 16. Then minus 4 times 1 times 2 give us minus 8 over 2. Then that will give us 4 plus or minus square root of 8 over 2. Then we know that this one implies two things. So okay, you find the square root of 8, that will give us a 2.8284. And this simply means this addition of it and the subtraction of that If you simplify that, that gives us a t to be 3.1414 seconds, or t is equal to 0.586 seconds for the value of the time we have to find. Then C part, you are going to solve that C part, you have to find the time taken when the object is 10 meters below the level it was thrown. So that means the height will be negative in this case, since it was below the height it was thrown. So that means the height will be negative 10 meters. Then the initial velocity is 20 meters per second. GC negative 10. And we're looking for time as well. So you're still going to use the same formula. If you pull it into it, you have minus 10 is equals to 20t plus half of minus 10 t squared. If you t will go, if I go here, you see be having this. Divide both side by 5, you'll be having this. Collect light times, you'll be having this as well, which cannot be solved using factorization method also, but you can use the formula method or complete square method. So using the formula method like I did in the previous slide, you go through this same step. You'll be having this, and after you solve it, you'll be having your t to be 4.49 seconds or negative sign. But our time can never be negative, so that means you're going to pick only the positive one. So t will be 4.4 seconds, approximately to 1 decimal place. Then the last question that you have to find the velocity with which the object hit the ground. So you are looking for velocity hit the ground. So the height was the total the height will be minus 20. So and the initial velocity is 20 as well, and the final velocity will be minus 10 meter per second squares as well. So if you put that into this equation of motion, we have v square equals to u square plus 2gh. Then what do we have? You'll be having v square, which is what you are looking for. You are looking for a final velocity, which will be initial velocity squared plus 2 into minus 10 minus 20. We simplify that, that gives us 400 plus 400. Give us v square to be equal to 800. Our v will be square root of 800, and our v will be 28.28 meters per second, which is the value of the velocity for we have to find for question number for D part of it. And that's the solution for question number 15 as well. And that is the solution for all the 15 questions that was asked from the student by the examining body, Wassce 2024 for the mathematics, the theoretical part of the questions. And I want to believe that you have been able to learn one or two things from this video, even as you have been following us step by step from the beginning to the end. And we want to appeal to you that if you are yet to subscribe to this channel, please click the subscribe button right now, so as to be the part of this family. And whenever we post information on this platform, you will be the first person to be notified. Don't forget to share this video on all the social media platforms that you belongs to, on all the groups that you belong to. Share it on those platforms, because there may be students who are in need of this material, and they don't even know about this platform. You will be the one to notify them by this by sharing this video. When they are aware of it, then they will be aware of this platform. Don't forget to drop your comment in the comment section of this video. Don't forget to like the video, and we'll see you in the next video. Thank you, and may the Lord bless you. Bye.